Hi students, in this video we are going to discuss about what is the actual difference between parametric and non-parametric methods. In this part we will be discussing about what actually parametric test means and what it mean by non-parametric test, and we will be discussing the actual difference between non-parametric test and parametric test, and we will be further going on, we will be knowing about when to use the parametric test and when to use the non-parametric test. First we will discuss about parametric test. Any hypothesis test that is based on the assumption that the population distribution function is known is called a parametric test. Parametric methods are based on the normality assumption because the theory behind the test was worked out with the normal population distribution. The resulting procedure is efficient for normally distributed data. So, from this we can easily understand that the parametric test is purely based upon like what kind of population distribution function we are going to use it, and further it is mainly important assumption, it is like it will be based on the normality assumption, and the theoretical thing what all has been developed in the parametric is purely based upon the normal population distribution, and at last it is more efficient whenever you have your data which follows normally distributed. Next we can discuss about further about parametric test. Some parametric test which is already existing and already discussed are t test, f test and chi-square test. It makes assumptions about the population parameter as well as the shape of the distribution. All parametric methods have at least one non-parametric alternative. The choice of the methods depends upon the assumption of the data. So, from this we can easily understand like we have large number of parametric tests like t, f and chi-square, and the most important assumption for the parametric test is like it should follow the normal distribution as well as the parameter should possess a shape of the distribution. Further, as we discussed earlier, for every parametric method there will be one non-parametric method. As I told earlier, like for sign test we have t test, for Wilcoxon test we have independent sample t test, for Matthew test we have independent sample t test, Wilcoxon sign rank test we have paired t test, like Kruskal-Wallis test we have one way ANOVA, like Friedman test we have repeated measures ANOVA. So, like that for every parametric method we have one alternative non-parametric methods, and the choice of the methods will be depend upon what kind of data you choose, like whether it is ordinal, whether it is a nominal or whether it is a continuous data. Next we can discuss about non-parametric test. We will be discussing about like how far it differs from the parametric test. They are based on some of the assumptions of parametric test, such as sample is a random sample. So, this is one of the assumption which parametric test also possess. It does not assume a particular probability distribution for the population like a normal distribution. They are valid for data from any population with unknown probability distribution. So, it is like they have the assumption what they have possessed in the parametric test, the only one assumption, that is the sample should be a random sample. The remaining things and all not required in the non-parametric test. That is the second point you can see there, it is like it is a population like normal distribution, we do not have any kind of assumptions over there, and it is valid for any kind of population. It may be any unknown probability distribution, we are not at all worried about what kind of distribution it follows. Next we will be discussing about further about the when to use the non-parametric test. So, when the data is nominal or ordinal, it is difficult to imagine a population distribution without treating them as whether it is at least interval. Next we can discuss about binomial test, sign test, Fisher exact test and quantity test are some of the examples for ordinal and nominal data. Next we will be having like Wilcoxon test, Matthew test, Kruskal-Wallis test and Friedman test are some of the examples for ordinal and quantity data. So, from this we can easily understand like if you have ordinal and if you have only one sample, then we can use the sign test or Fisher exact test, and if you have ordinal and nominal data and if you want to compare between the groups, then we can use the Wilcoxon test or Matthew test, and if you have more than two groups then we can use Kruskal-Wallis. If you have repeated measures for more than two groups then we can use the Friedman test. In this table we can easily understand when to use the parametric test and non-parametric test under certain situations. Like first thing you can see here, assumed distribution. So, in assumed distribution, in case of parametric, we should have the assumption that it is normal, but in case of non-parametric, we do not have such assumption. It can be following any kind of distribution. Second thing is assumed variance. So, what kind of variance we should have the assumption? It should be homogeneous. Homogeneous means the variance should be equal or same, but nothing required in the non-parametric. Then what kind of data we are going to use it? That is typical kind of data what we are going to use it for parametric. It should be ratio or interval, in the sense it should be like a continuous variable, then only we can fix for the normal distribution. But in case of non-parametric, even if we have continuous or ordinal or nominal, it still non-parametric test will work. And what kind of relationship should exist between the data set? That is data set relationship. In parametric, it should be independent for the comparison, but in non-parametric we do not have such kind of assumption. It can be independent or it can be dependent. Even if you have rank data, still it works. Then what kind of measurement we are going to use it? Like central measures. In parametric, mean, as I told you earlier, for the parametric test we will be using mostly mean and variance, but in non-parametric test we will be discussing about median or ranks. And what are all the benefit of using parametric test? We can draw more conclusion, in the sense it is like we will be giving more precise and more vulnerable results we can give, but non-parametric is something like simplicity, but still it is less affected by the outliers. So, in this video we have discussed about parametric and non-parametric test, and what is the actual definition of parametric test and what is the actual definition of the non-parametric test, and we have discussed about the difference, and we have discussed about like under what situations we have to use the parametric and non-parametric. So, in the upcoming video we will be discussing about what are all the application and scope of the non-parametric test. Thank you.